guys, correlation is just going to be, here's the deal, guys. And you talked about these a long time ago in Algebra 1 when you did correlations. And they would show you pictures just like this. Okay? And they would go, and probably some of you in your jobs, you have to look at scatter plots like that where it measured something and you have to go, oh, well, this is bad because this is going up and this is too. Okay, so like what it is you're supposed to look at this scatter plot and you're supposed to say, okay, well, is there a strong positive correlation, strong negative correlation? Is it weak positive, weak negative? And for us in particular, we talk about them being linear. So can you draw a line? Does it look like a line of best fit can go in there? So we start off with just this first picture in A. It's a positive linear correlation, okay? Because pretty much when we talk about a positive linear, if one value gets larger, then the other value also gets larger. As one value becomes larger, the other does as well. Okay? In our second picture, we have a negative linear correlation. So when we say negative, it's got a negative slope because that line's going down. What happens on this one, as one value gets larger, the other gets smaller. Okay, so what's happening on that x-axis, and remember the x-axis is the horizontal axis, so this is my x, this is my y. As my x increases, those y values are decreasing. So it causes that line or that data to fall, so it is a negative correlation, okay? Our third picture, they're going to go ahead and they're classifying that as linear. It is weak because you can't tell real well that it's that it actually is positive and that it is linear. So it's kind of going up, but it's a little all over the place. So we call it a weak linear. It wouldn't be negative. It's going to be positive. Okay. This next one on D, we have a positive non-linear. Guys, this is going to be some kind of exponential. If you'll look, it's got a curve to it. Okay. So if the data, when you put those points on there and you draw that scatter plot, if it makes some type of curve, then it's not linear because it's not a straight line. Okay? On E, once again, we don't have a straight line. So we are looking, it looks curved. So it's a negative nonlinear. Those values are still falling, okay? Remember we read a graph or that scatter plot from left to right, okay? So as we're reading from left to right, it is falling. It's just not linear. Like in D, if we read left to right, that data is going up. So as X gets bigger, Y is getting bigger. So it's positive, but it's not linear, okay? So we have example 1. It says, if large values of one variable are associated with small values of another, then the two variables have a negative association. Okay? You got a large with a small, it makes a negative. Things are falling. Okay? If two variables have a positive association, then large values of one variable are associated with large values of the other. Okay, for it to be positive, we need a large. 3, if the points on the scatter plot tend to cluster around a straight line. That's your key right there, straight line. The variables plotted have a linear association. Okay? Not too bad. Some of you will like 4.1 and 4.2 much better. There's a lot of calculator work on it, and it's stuff like you've done on the calculator before in previous math classes, like in high school. Okay, so 4 says, and I promise you there was some Algebra 1 teacher that made a really big deal about correlation somewhere in your life, because she wanted you to get those like 2 questions right on the STAR test, because she knew that would help her. For each of the following scatter plots, state the type of association that is exhibited. So we're going to choose from positive linear, negative linear, positive nonlinear, negative nonlinear, and weak linear. Okay, well, what do you think about A? Negative, what kind? Linear, good. It pretty much, we can draw a straight line in between there. Okay, and it is falling, so it is negative linear. Okay, how about B? It is positive. Is it going to be linear? Nope, it makes a curve. Okay, something is growing what we call exponentially there. That's exponential growth. It's positive nonlinear. And I only point that out because I just got through teaching exponential growth lesson. C, what are you thinking? Positive linear? Looks like some kind of whale to me. Positive linear? I like whales, but... Okay, we got a blob on D. What was the blob a while ago? Weak. And we went ahead and said linear. That's our only choice for weak. Okay. And then on E, it is falling, so it is negative. Does it have a curve to it? Yep, a little bit. So it's going to be non-linear due to that curve. Okay, so those are pretty friendly there. Not too bad. Number 5, for each of the following pairs of variables, determine whether the association is positive or negative and explain why. Would the association between outdoor temperature and consumption of heating oil be positive or negative? Guys, they mean heating oil like to run a furnace. Something like that, to warm a house, that kind of thing. So it gets hotter outside, and we're talking about the temperature goes up and the consumption or the purchase of heating oil. So do you think as it gets warmer outside, is the buying of heating oil going to go up? No, it's going to get smaller. It's going to go down. So one thing's going up, the temperature goes up. Temp goes up, use of heating oil goes down. So if one thing's going up and one thing's going down, so that's one getting larger, one getting smaller, it is negative. Good. Okay. This next one is something that we do preach to you guys. It's not always the truth. I'm living proof of that. But the number of years of education a person has and the person's income. So let's think about it. Say all you have is a high school diploma, and then you go back, you get an associate's degree, you get a different job with that. Then after your associate's degree, you do get a bachelor's degree. especially in the healthcare field, I do think it works this way. The more years you've gone to school, as far as like you start off with RN, then BSRN, then they call it MSRN. Okay, so you're a nurse practitioner. Does your income go up as the number of years you've gone to school go up? Yes. They have done studies over it, and that is supposed to happen. Okay, because you're talking about now. In our world of education, college professors don't make that much. I mean, you can have a PhD and you're still not going to make that much more. But when they poll people and they do studies like this, you're looking at doctors, you're looking at lawyers, and I mean, you're looking at, even if you're a certain kind of surgeon, you've then gone to school even more years than the normal doctor years, like 8 years. So it would be positive. Okay. And for many of you, that is why you're back in this room right now. It's like, okay, yeah, I need to make more money. I will say this, even in education, at least in K-12 education, most school districts, if you have a master's degree, you do get paid more for a master's degree. Some districts will pay you more if you have a PhD also. So when I first got my master's degree, I was still teaching high school math, of course, and I did make more per year because once I finished my master's degree. I think at the time, the school was paying me an extra $1,500 a year, which isn't a lot, but, so it takes some time to eventually pay back that master's degree. But it has allowed me to get other jobs where I do make more money because I do have that degree. Okay. Correlation coefficient. This is where we're going to use the calculator quite a bit. Starting now. Correlation coefficient is a numerical measure of the strength of the linear relationship between two variables that is not affected by the scale of the plot. Correlation coefficient is generally, guys, it is a number between -1 and 1, okay? And the closer your number is to 1 or to -1, the better the line of fit. The tighter that data will be. Like when we looked at the scatter plots over here, this one right here, A, the negative linear, the first one, it's going to have a higher correlation coefficient. It's going to be closer to -1 because it is falling, so it's negative, but it's pretty tight on that linear. Okay, C will have one closer to 1, a positive 1, because it's positive. Okay, right here, this weak linear, it's going to be close to 0 because there's not much making it linear. Okay, so let's look at number 6. The National Assessment for Educational Progress is a U.S. government organization that assesses the performance of students in schools at all levels across the United States. The following table presents the percentage of 8th grade students who were found to be proficient in mathematics and the percentage who were found to be proficient in reading in each of the 10 most populous states. Okay, so we've got a table. It says percentage proficient in reading in that middle column, my second column. And then my third column, I have percentage proficient in mathematics. It says construct a scatter plot with reading proficiency on the horizontal axis, okay, and math proficiency on the vertical axis or the y-axis, okay. So we want this on the x-axis, and we want this on the y-axis. All right, is there a linear relationship? So here's what we're going to do. I'm going to see if I can split my screen. I don't need those anymore. Let me go over here to y'all's 84. Let me clear it. There's one thing that I want you to make sure that your calculator is on, it has diagnostics on, because we'll need to find that correlation coefficient. My handheld one originally didn't have it on, and had to look up how to turn the thing on because I knew it would produce it. If you will go to second 0, and that's your catalog where you have everything, and then if you'll go down to the D's and find diagnostic on, if you can find it. Okay, so there's my diagnostic on. Y'all can't see that. There you go. See how I'm right there? Hit enter on it, and then it should pop up on the main screen, on the home screen. Then hit enter again, and it should say done. Okay, so we'll see if mine will stay on. But when we go to find those linear regressions, the way you find a correlation coefficient is to force a linear regression. And in order for that R to pop up for you, that diagnostic has to be on, okay? Okay, so we need to, let me see what page I'm on over here. All right, so we're gonna go to, we wanna do a scatter plot. So the first thing we're gonna do is we're gonna go to Stat, and we're gonna edit. And I'm gonna put what I want as the X values, which for you guys was the, let me do a split here. Were my reading values, right? So these are my L1. I'm gonna say, these are my L1s. Why am I not writing? No, don't copy, okay. These are my L1s, my reading, my math is L2, okay? See, y'all are over there beating me. 73, 75, 66, 75, 79, 79, 73, 67, 74. Okay, then I'm gonna go over here, and in L2, I'm gonna put my math percentages. And we want to see if there's a linear relationship between these, is what we're trying to produce. And so we're going to make our calculator do a scatter plot here. Okay, so I get those in L1 and L2. Let me go ahead and make that full screen there for you guys. Okay. Now, I'm going to go to second y equals. So I'm going to push second y equals, and notice my plot 1, y equals is at the top. It should be second y equals. My plot 1 is off. I'm going to hit enter on number 1, and I'm going to turn it on. Yours was already on? Okay, that's good. And it could have been. And you'll notice on my top, I have the little dots highlighted. That's a scatter plot, okay? See, this is where we went when we did our box and whisker plots before. Do you have some dots? Okay, and then your X list, your X values, you put those in L1 because those were your reading values. You put your Y list was L2. You may not have the mark and the color. It doesn't matter. That's just telling you how they're going to color it. And that's to the, do you have the L1, L2? Okay, let me look. I may have to type X list. Oh, it's because you got him on his box and whisker. You go back up here and hit enter on the dots. Okay, now you're in L1 and L2, but your mark can just be it'll make a circle, kind of like a box circle, okay? Okay, so then I'm gonna hit graph, which is on the far right, and you probably won't see anything. It looks blank like that, okay? Well, here's the deal. We got to think about what our scores really are, okay? We're going to set our window there. Guys, you've got averages of what kids have made on a reading test and a math test, right? So I'm going to go to window, which is the button right beside y equals, okay? Now I'm going to make that, guys, we're only looking at positive values, right? Those reading and math scores were positive values. So I'm going to set my X minimum to 0 and my X maximum to 100. Because typically that's what a kid scores on a test, right? 0 to 100. Somewhere on there. Same thing on the Y. I'm going to do 0 to 100. Oh, sorry. 0 to 100. Now, I'm going to change the scale. You don't really have to. I do because I don't want to look so smushed up. I'm going to count by 5s. Because we don't really have any kids making like below 60, 50. Oh, they're in the math thing. Somebody made 59. Okay, so I'm going to have it count by 5s. Okay? Don't worry about those other numbers. Don't worry about that other stuff. Okay? So everybody got an X min, X max, 0 to 100, Y min, Y max, 0 to 100. Oh, fix your X scale, 1. And my Y scale, oh no, that should be, what happened? X scale's 5, Y scale's 5. Oh, I changed the wrong thing. Do y'all know what my resolution said?
1.
Was it 1? Okay, I'm going to change it back to 1. All right, so here's what I've got. I've got 0 to 100, and on my X's, I'm counting by 5. That's what the X scale means. My Y min, 0 to 100, counting by 5s again. X resolution, leave it at 1. Okay, let's graph it. Now we can see it better. Everybody got some little dots going on there? You can tell it's positive. You can tell it's somewhat linear, right? Okay? So we go back over here and we say, it says construct a scatter plot. We did. Is there a linear relationship? Yes. Positive, linear. Okay? Now it says compute the correlation between reading proficiency and math proficiency. Is the linear association positive or negative, weak or strong? Okay? So that's why we turn on that diagnostic on, so we could do it. Now, you can do this a couple of different ways here. I'm going to go to, I just second quit and I went back to my home screen. That's what I did. I just second quit. Okay, so we're going to go to Stat and we're going to go over to Calc. Now, personally, I always pick number 4, the linear regression on number 4, because it's AX plus B. Sometimes on some of the problems in here, they like you to pick number 8, where B is the slope and not the y-intercept. Now, just coming from an algebra standpoint, and you guys have always been in algebra, that's why I always say pick AX plus B, because you think of B as your y-intercept. And that's just kind of still ingrained in you sometimes. It still comes back. Either one will give you the correlation coefficient, okay? So I pick 4. And here's one thing we have to be careful of if it comes up. Okay, X list is L1. That's good. Y list is L2. Leave the frequency list empty. Some of them may come up with the L2 already there. Clear that out, okay? We don't want to store it anywhere. If it says store regression equation, you're not wanting to store it anywhere. We could store it in Y1 and then graph it together. We're not going to. Just go ahead and calculate. Hit enter. And here's what we got. They give you your linear regression. What you're looking for is just R. That's the correlation coefficient. Okay? You want R there. So we go, okay. R equals 0.8086, 8086, okay, approximately. And that means, since it's positive, it is a positive linear correlation, okay? It's positive linear. We know it's fairly linear because it's close to 1. It's 0.8. Okay? The closer it is to 1, the stronger of a linear correlation it is. Okay, so we go, compute the correlation reading. We did, is the linear association positive or negative, weak or strong? It's positive, and it is strong because it is close to 1. Okay, so not too bad.
So what would be considered weak? Is there a number?
Closer to 0. Anything that's close to 0.
If it's a 5?
You won't get it. Your correlation coefficient will always be between -1 and 1. So it's always going to be a decimal. It'll never be over 1. It'll never be less than -1.
If there's a 0.5 something.
Like 0.5 something, he's kind of weak. Yeah, he's a little weak. He's not bad weak. They shouldn't give you. They shouldn't give you something like that.
It would be obvious.
Yeah, it should be obvious. It'll be like a 0.1, or like sometimes you can get 0.012, you know. So when you're getting, if it's below 0.5, he's going to be weak for sure, is what I would say. Okay? If they do that to you, they're not very nice, which sometimes they're not very nice.
I'm not worried what you're going to do. I'm worried about
Yeah, on the test, or the homework. And I will go back and look at your tests and make sure they didn't cheat you, because sometimes they will. They'll trick you, cheat you. Oh, they'll cheat you even if you put like parentheses, space 1, comma 2, close parentheses. You put that space in there, they're kind of wrong. And I'm like, you need to stop yourselves, because that's just some programmer.
It wasn't wrong.
Yeah, and you don't know it when you're taking the test, you know. But number 7, for which of the following scatter plots is the correlation coefficient an appropriate summary? Okay, so now here's where this comes into play. Okay, talking about an appropriate summary, guys. You only talk about a correlation coefficient if it's linear, okay? Now, your calculator will produce one, and your calculator will force a linear regression no matter the data. I mean, it can be as skewed as B right there, and it can still come back and it'll try to make some linear regression for it. But it's not linear. It needs to be linear in order for us to use a correlation coefficient. So we can make that little note. The data needs to form something linear in order to appropriately use the correlation coefficient. Okay? So, we know that B is going to be out, right? So B's out because he's not linear, okay? I'm going to tell you right now, C is out. Why is C out? What do you see? Who's flung off to the side over there? You got an outlier right here, okay? So, we do not need outliers when appropriately using the correlation coefficient. Okay, so we can't use B because the scatter plot's not linear. We can only really talk about that correlation coefficient if the data is linear, which B wasn't, so B's out. We can only use the correlation coefficient if we don't have any strange outliers flying around. And so C is going to skew that linear regression and will skew that correlation coefficient because of that one little outlier flying out there. So he's not appropriate either. We can't really use the correlation coefficient on that one, so that just leaves me with A. Okay? That is 7. And then 8, and this is the end of 4-1. Okay, this one's kind of funny. We don't typically use this particular example when we're talking with high school folks. We talk about the sale of, okay, it's called correlation does not cause causation, okay? So here's the example we usually use. Okay, it's the summertime. The sale of ice cream goes up in the summer. The crime rate goes up in the summer. Like aggressive assault in particular goes up in the summer, and it does. If you are looking at an impoverished community, assault goes up in the summer. So, well, assault's going up in the summer. The purchase of ice cream is going up in the summer. There's going to be a positive linear correlation there. So, buying more ice cream in the summertime causes people to beat each other to death. Okay? Yeah, no, so that's a prime example of correlation. Those two are correlated. They're positively correlated. As the purchase of ice cream goes up, the assault goes up. Okay? Now, but that one doesn't cause the other, okay? The crime rate of assault going up doesn't cause more people to go out and buy ice cream, okay? I tell you what causes both is that's the rise in temperatures. And if you look at a impoverished community that does not have central heat and air in the summer, I mean, you're already hot, the body is stressed, and then more things happen, so assault does go up, okay? The people in the community over are the ones buying the ice cream because you can't afford to buy the ice cream because you're beating people up. Anyway, so that is a true case of correlation. Just because they're positively correlated or even negatively correlated, just because they're correlated doesn't mean one causes the other, okay? So, example 8, it says, an economist discovers that over the past several years, both the salaries of U.S. college professors and the amount of beer consumed in the United States have gone up. Thus, there is a positive correlation between the average salary of college professors and the amount of beer consumed, okay? So, the pay of college professors has gone up, the purchase of beer has gone up. The economist concludes that the increase in beer consumption must be caused by professors spending their additional money on beer. Explain why this conclusion is not necessarily true. And the answer literally says correlation does not imply causation. Okay? And then they go on to say, we do not know who is purchasing more beer. Okay? And you don't. They didn't poll They didn't check what all the people that were purchasing the extra beer did for a living, okay? They just went, oh, the salary of college professors went up, the amount spent on beer went up. Oh, well, college professors are buying beer, okay? And that is all of 4.4.